In the name of God, hello everyone. I am Dr. Ahmad Fahmi, a faculty member at the university and the innovator of GEOtExcel project, Soil Mechanics and Foundation Engineering Excel Spreadsheets. I invite you to watch a new video from the GEOtExcel project. Thank you very much. GEOtExcel, Geotechnical Excel Spreadsheets, Foundation Engineering, Bearing Capacity Problem 1, Problem Sheet and Solution Sheet. A foundation has a depth of 1.5 meters. In Solution Sheet, DF, the depth of foundation measured from the ground surface, 1.5 meters. The soil supporting the foundation has an internal friction angle of 30 degrees and cohesion of Cprim equals 10 kN per square meters. Solution: Cprim, soil cohesion 10, and Fprim, angle of friction of soil, angle of internal friction of soil, 30 degrees. The unit weight of soil is 18 kN per cubic meters. In Solution Sheet, with a factor of safety 3, calculate the ultimate and allowable bearing capacity of the foundation, assuming general shear failure according to the Terzaghi's method. Disregard settlement considerations for now. The groundwater level is deep and the load on the foundation is not eccentric. In solution, factor of safety equals 3. A. For a strip foundation with a width of 2 meters. Solution: B equals 2 meters. Shape factors SC, SQ and S gamma. SC, cohesion contribution, SQ, surcharge contribution, and S gamma, unit weight contribution. For strip foundation, SC equals 1, SQ equals 1, and S gamma equals 1. For square foundation and circle foundation, you can see the values. Now for strip foundation. Q definition. Surcharge. The soil above the bottom of the foundation can also be considered as being replaced by an equivalent surcharge. Q equals gamma dF. Q equals 18 multiplied by 1.5 equals 27 kilonewton per square meters. ANSI definition. The bearing capacity factor related to the contribution of soil cohesion. NQ definition. The bearing capacity factor related to the contribution of surcharge. N gamma definition. The bearing capacity factor related to the contribution of unit weight. In bearing capacity factors spreadsheet, in different methods you can calculate the preprime-related bearing capacity factors using these equations or by referring to the provided table. For example, in Terzaghi's method, in Mohr-Coulomb method, basic method, and Hansen's method. For Terzaghi's method, ANSI equals NQ equals and N gamma equals these values. In each method, you can calculate the related bearing capacity factors using this equation. For example, in Terzaghi's method, you can calculate NC using this equation, NQ using this equation, and N gamma using this reference. Ultimate bearing capacity equals SC supreme NC plus SQ Q NQ plus S gamma half gamma P N gamma equals this value. Allowable bearing capacity equals ultimate bearing capacity per factor of safety equals 440 kilonewton per square meters. In this equation, ultimate bearing capacity QU, we have three terms: SC supreme NC, SQQ NQ, and S gamma half gamma B N gamma. You can key the detailed calculations here. SC, SQ, S gamma, supreme, Q, NC, NQ, gamma, B, and N gamma. For strip foundation, Q equals Q all multiplied by B. For square and circular foundations, all the calculations are the same as for strip foundations, but the shape factor values must be adjusted accordingly. For a square foundation and for a circle foundation, calculate the ultimate and allowable bearing capacity of the foundation. Okay, for square foundation, SC equals 1.3, SQ equals 1, and S gamma equals 0.8. And for circle foundation, SC equals 1.3, SQ equals 1, and S gamma equals 0.6. For strip foundation, for square foundation, and for circle foundation, you can see the variations. Ultimate bearing capacity variations. You can see the variations here by changing the options. Okay, for square foundation, Q equals Q all multiplied by square B, and for circle foundation, Q equals Q all multiplied by the area of circle. In this spreadsheet, you can see the variation of QU, ultimate bearing capacity, by adjusting different parameters. As the width of the foundation B increases, the ultimate bearing capacity QU increases. Conversely, as the width decreases, the ultimate bearing capacity decreases. As you see, the variation is linear. As the internal friction angle of soil fibrem increases, the ultimate bearing capacity increases. Conversely, as the friction angle decreases, the ultimate bearing capacity decreases. The variation is not linear. The variations for both factors P' and P. As the depth of foundation dF increases, the ultimate bearing capacity Qu increases. Conversely, as the depth decreases, the ultimate bearing capacity decreases. The variation is linear. As the cohesion coefficient of the soil cyprim increases, the ultimate bearing capacity Qu increases. Conversely, a decrease in cohesion leads to a decrease in ultimate bearing capacity. As the unit weight of soil, increases, the ultimate bearing capacity Qu increases. Conversely, as the unit weight decreases, the ultimate bearing capacity decreases. Bearing capacity, special cases. Part D of the question. Consider the special cases where cyprim equals 0, dF equals 0, and cyprim equals 0 and their combinations. Special cases. 1. Non-cohesive soils. Cyprim equals 0. SC cyprim NC equals 0 because the cyprim parameter equals 0. Zero foundation depth, F equals 0. In this case, SQQ NQ equals 0 because F equals 0. Ultimate bearing capacity equals 758. In general condition, F equals 1.5 meters and your ultimate Q equals 1322 kilonewton per square meters. Three, undrained soil conditions. Cyprim equals 0. In this case, S comma half comma B n comma equals 0 because n comma equals 0, NC equals 5.70 and NQ equals 1. In this example, you can see the ultimate bearing capacity equals approximately 100 kilonewton per square meters. And in general, problem with cyprim equals 30 degrees, ultimate bearing capacity equals 1322 kilonewton per square meters. Four, combination 1. Cyprim equals 0, and TF equals 0. In this problem, SC, C' and C equals 0 because the C' parameter equals 0, and SQ, Q, and Q equals 0 because TF equals 0. You can compare the values. 5. Combination 2. TF equals 0 and T' equals 0. In this case, SQ, Q, and Q equals 0 because TF equals 0, and S comma half comma B and comma equals 0 because N comma equals 0 because T' equals 0, and NC equals 5.70. You can see the problem for my students with different IDs and different parameters.
Geotechnical Excel, GEOtExcel.